depth below the surface of the earthquake, and then the size corresponds to the magnitude of the earthquake. And this is seismicity since 1990 to a few days ago. And this is the relative plate motion. Here's Haiti. You can see there's a lot less seismicity over the same amount of time in Haiti than there is in Chile. And this is a direct reflection of the difference in the relative plate motion. The relative plate motion between Haiti or between the Caribbean and North America is on the order of 2 centimeters per year. But if you look at NAFTA, South American convergence, that's on the order of 11 centimeters per year. So 5 times the convergence. So that's one of the primary differences between the two. Okay, just for people who aren't geologists, what is an earthquake? And it's the sudden release of energy that produces seismic waves. And they don't just, and that earthquakes can be caused by a large number of things. They don't necessarily just have to be plate motions. So we can have fault ruptures, volcanic eruptions, landslides, nuclear bombs, for example. And in fact, it was the proliferation of nuclear testing that really funded a lot of early efforts in seismology, as we could use the earthquakes that the nuclear explosions produced to then verify whether or not nuclear testing was going on. So we produce waves. When we generate an earthquake, we produce what we call body waves, which are waves that radiate through the body of the Earth. And there are 2 types, P waves and S waves. P waves are called the slinky waves because the displacement associated with the wave is parallel to the direction the wave propagates. So if you were standing here, you'd move back and forth. The S wave is the one where people call it more analogous to a jump rope because the displacement is up and down, although the wave is moving in this direction. And so if the S wave came in, you'd go up and down. Then we also have surface waves that are produced that travel along the surface, and those are called Love and Rayleigh waves, and they're mostly like this, and they can also do a lot of damage. But basically, when we look at trying to determine the type of earthquake and information about the earthquake, we look at what's called the body wave. So here's just a brief summary of what the Haiti earthquake was. We all know sort of what time. Here is what's called the seismic moment. This is magnitude 7. And the seismic moment is a measure of the area of the fault that ruptured, the amount of slip that ruptured, the amount of slip that occurred, and the strength of the rock. In addition to looking at what the energy is or the amplitude of the arrivals of the body waves at the seismometer. So the energy radiated was 10 to the 15 newton meters. It occurred at a depth of 13 kilometers. And this is very important. It was 25 kilometers west-southwest of Port-au-Prince. So it was very, very close to the city, very shallow. Okay? Those 2 parameters are very important. And we all know the tragic numbers of what happened in Haiti. Now if you look at Chile, and this is just showing you a schematic of a fault, where here we have where the earthquake ruptures along the fault plane, and then the energy radiates in every direction. Here you can see the seismic moment was much, much larger at 8.8. Energy radiated was an order of magnitude more. The depth, 35 kilometers, as opposed to 13. 60 miles north-northwest of Chiapas, 300 kilometers south-southwest of Santiago. 700 killed, thousands injured, 1.5 million displaced. Okay, so the Chile earthquake is much larger than the Haiti earthquake, but the Haiti earthquake is shallower and much closer to the major population center. Okay, so here's just a schematic to illustrate the difference between the 2 earthquakes. So this is the distribution of the amount of slip or displacement along the fault during the earthquake event. Okay? So here is Haiti, and essentially just an estimate of what the size of the fault rupture was, and then this just shows you the slip directions, and we'll look at this piece again later. And this fits right here relative to Chile. So you can see in Chile that the fault was much, much larger. The slip was larger, but the fault area was larger, and this explains why the energy release was so much larger. It occurred over a much larger area of